So I'm Lasse Christensen from Danske Bank. For those of you who don't know, Danske Bank is the biggest bank in Denmark, and we work across the entire Nordics, serving in our markets. We serve private customers, small and medium-sized businesses, corporate and institutions. And in Danske Bank, I sit on the business side in the fraud management area, where I work with advanced analytics projects primarily related to payments, which is the case I'm going to present today, but also within cards and mobile payments. So basically what I'm going to talk about today is a bit about what is fraud in relation to payments, the platform we built together with Think Big, what are the challenges now that we actually need to scale up, and some of the work we've done in relation to deep learning. So if we look at the fraud landscape, how it looked like 5 years ago, it was dominated by three groups. You had like the fortune hunters trying to get a quick win by doing some quick stuff without really reaching that many victims or earning that much money. Then you had the kind of organized criminals. They had the know-how how to translate this fraud into like a viable business. And you had these hackers who actually could program the tools, but they didn't really know how to translate that into money. Then as we kind of fast forward 5 years, this kind of new emerging threat was coming up, fraud as a service. So what fraud as a service is basically that you can go to the dark web, there you can buy like the data, the services you need in order to perform the fraud you want to do. And as a normal business, of course, they also have money back guarantee and also 24/7 hour support. So for the fraudsters, that's a great thing. But for Danske Bank, that really poses a challenge because we are kind of transitioning a lot of our project to the digital space. And when we see this kind of threat, that will also like relate to us. We're seeing a lot of these digital threats. So in order to like keep our customers safe and the bank safe, we need to have barriers in place to be able to fight this fraud. And advanced analytics or machine learning, that's one part of the puzzle. So when we talk about fraud on payments, I brought a couple of examples here to illustrate that. So for example, fake invoices, our customers are receiving an email with an invoice for goods they never received. You have like the bank account details or beneficiary account details where a customer is supposed to transfer money to a company or person whose email address has been compromised, and the fraudsters then change the account details for the claim. Then you have malware, which is kind of malicious software that's installed on your device. So that could be on your mobile device or your laptop. And that could, for example, be that when you log onto the web bank, it has an overlay that kind of sits there and extract your credentials. Then you have the CEO fraud, which actually can result in a huge loss. But what this is basically that often it's a secretary or someone in accountants receiving an email, presumably from the CEO, like asking them urgently to transfer money. And in this case, the fraudsters are actually really clever because some of the cases, they kind of compromise the CEO's emails. They see what see how's his normal patterns, how does his like write to other people and so on. And then at some point, they just put in the attack. And then, for example, like Friday afternoon, they ask for an urgent transfer. It's like secret transfer. So that's also a very difficult one. Then we have the phishing case where you would receive an email, for example, from the tax office or from the bank, trying to persuade you to click a link. And when you enter that website, you're kind of persuaded into uploading your credentials and your NIM-ID so the fraudsters can access your account. But when we talk about fraud and how we actually prevent it, it's all about knowing our customers. So KYC, that's know our customers, but in fraud, it also means another thing. You need to know your criminal. So if we start by looking at what kind of data do we use to know our criminal, so of course we have some kind of information about what kind of devices are they using. Are they normally using a laptop? Are they using mobile devices to make the transfer? Where are they actually performing the transfer from? And where do they normally live? Then you have like the entire transaction history. So who do they normally transfer to, and when do they perform these transfers? You have some basic customer details about the customer group, the gender, the age, and so on. And all of these can kind of constitute a kind of profile of the customer. And when you look at like fraudulent transactions, you could imagine that you would see one of these kind of features or data sources having some kind of anomaly compared to the normal behavior, which is highlighted by these. So for example, you could have like in the device information, it could be that the transfer is performed by a device the customer would normally use or something like that. So for this project, for Danske Bank, it's about we need to be ready to fight these fraudsters. So currently we have a rule engine running. It's scoring all our transactions, and the rules in the past were kind of based on gut feeling. So the people from my department who knows a lot about fraud, they set and kind of defined these rules in a simple fashion. So for us, it was about, we needed to, how could we improve this setup? And that was where machine learning comes into the picture. So we wanted to like improve the detection rate. But actually, our system, the rule-based system, actually performs quite well, but we needed to be better. And one of the big things was false positive, because it kind of, the people that, the investigators that look through the cases, we could actually spend their time better elsewhere instead of dealing with all these false positives. And of course, we wanted to reduce the loss. And as I just mentioned, this kind of fraud, it evolves very fast. The fraudsters are quickly to adapt to new situations. So we also need to be able, in our fraud prevention setup, to be able to like handle that kind of change fast. But if you look at it from a kind of broader perspective, from Danske Bank's perspective, we also wanted to have a place where we could like productionize new machine learning model. We wanted to have like a analytics blueprint for putting new things into production. And of course, we wanted to have this kind of data-driven approach instead of like gut feeling. And I can say, so we ran this project for 6 months, and I joined a bit into the project. And my role at that point was a kind of a product owner. And the project was developed in collaboration with Think Big. So if we see it, how is our platform actually? So we have all the transaction coming in from this e-banking and business online. They're hitting the old mainframe where the fraud engine is located. And what happened before is the fraud engine would either like mark it for verification, flag, is this fraud or not? Then the transaction would go to the investigators that would look into details in this transaction. Is this fraud or not? And actually, in some cases, they needed to call up the customer to verify if this was fraud or not. Then if it wasn't fraud, the payment is proceed, and otherwise it's kind of locked into our system and the payment goes back. So in the part of this project, we wanted to augment our existing system with this box up here, which is the platform we've been building. So basically what happens is that the fraud engine calls our system via a pops-up message broker, and the platform takes the transaction, sends it to a queue, and then it sends to this enrichment database where we enrich the transaction with things like customer data, aggregated historic transactions, and these kind of things. Then the enriched transaction is sent to our model worker, where we have the option of having different models running parallel to each other. So the transaction is sent to the model, and they're executed in parallel and combined in an ensemble fashion. And currently we have logistic regression and gradient boosting decision trees running. Then the score is returned back to our platform or to the fraud engine, and then actually processed in the same way as it was before. So if you look at the tooling for this kind of project, we used Hadoop Hive for kind of the data management part. The data analysis and modeling part, we have like Panda, Anaconda distributing running with Python, Spark for like processing the data. We use primarily, so far we used scikit-learn models, but also, as I'll talk a bit, we looked into TensorFlow and Keras on top of that in relation to deep learning, and we use Git and so on for version control. For the actual deployment of the models to the platform, the platform engineering team uses tools like Jenkins and Chef. And if you consider the actual platform, what it consists of is like different open source tools. We have the Cassandra database, RabbitMQ, the different microservices are written with Java and Python, and you have scikit-learn models running in production. But in theory, you could expand what kind of models you ran there eventually. So from my side, it's a big project running this, and of course it was. I mean, we took from idea to production in 6 months. So in that sense, it was a good success. But of course, in these kind of projects, there are always a lot of challenges, and in a forum like this, it's very interesting to share these challenges. And I think yesterday we had a lot of talks regarding like the whole process of taking a data science project from end to start. I think some of these findings are also from there. So if we look at like management and business side, so from my point of view, you will really need to like have clear expectations on what can we actually expect when going into production and communicate about that. It's not like you need to be careful when you say that, okay, it's just going to perform super duper big, because it's never going to be like that from the beginning. And the business needs to be aware of this. Also, if you kind of have this agile approach, you also need to consider where you kind of have an iterative process for developing your models and the platform, that the business is aware of this, and the way you kind of fund the project is kind of made for that. Yeah, that's also related to agile. Then then there's also the thing about data, and that's always a big issue. And on this project, it was also a big issue. Just like the labeling, it's also from in the project, it was very manual. So all the fraud labels, what is in an Excel sheet, and you had to combine them with all the data, and that was very troublesome. And also when like looking forward, going into production, it is viable that you have, when you need to automate things, that you have like a data and Excel sheet. So we're also building systems to kind of have that more automated. Then in relation to trading data, I think you should really be careful about actually when you create your trading data set, don't create a lot of, use the data you're actually going, or select the features you're going to see in production. There's no need in like creating a big data set with a lot of features and then do exploratory analysis on those if you're never going to see them in production, at least to begin with. So like, if you want to move fast, then focus on the actual features you're going to see in production. Then, of course, in such a big project, you will have like different platform and different interfaces. And along the way, you will actually make some decisions that might actually impact how you can run models later on. For example, in our case, it might be that when we scale, there are some issues that we need to take care of later on. Then there's the whole testing part, not only the models, but actually the entire platform. You need to perform end-to-end here. And it's not only about seeing the platform as an isolated part, because you actually need to see like the whole picture, the whole flow with the interfaces and so on. One example is what happened for us actually was that because of some problems on the other side of our platform, that actually resulted in difficulties for us in creating these kind of training data from the logs, which kind of set us back. Then again, the metrics, it's about aligning with the business, making sure that your business metrics are aligned with your data science metrics, because that's not always the case. Yeah, so now we're in a situation where we have kind of accomplished part of our transaction are being scored here. We have seen a false positive reduction about 30%, but we need to scale up and we need to improve. So here at this point, we're going to face a lot of challenges, that's for sure. So for Danske Bank, for scaling up to have all our transactions on this platform, this means that we actually need to be able to, when we have like peaks of transaction, we need to be able to score 400 transactions a second. And that just as the platform as a whole, that would actually pose some challenges. But of course, when we have all these kind of transactions coming onto the platform, we also need to have different models running in production. And of course, this will actually lead to more management. So what you don't want to end up in this case is, you don't want to end up as this poor data scientist just sitting there. He has to be bogged down with a lot of manual work and just being not being able to execute fast. What you want to end up is that you want to be this happy guy that can actually sit back, drink a coffee, you have all the processes in place, and you can focus on like the model building and actually bringing value to the business by, in our case, improving the models for detection fraud, and also reducing false positives. So how can you go about doing that? I tried to outline our view on what is the life cycle of a model here. So to begin with, you have like the model development phase, the retraining phase. And what's important there is that you really need to have your data pipelines going. They need to be tested and validated so you can actually execute fast. So in our system, we track all the logs through the systems, and we combine them with these kind of the fraud data. And you need to ensure that these pipelines are really good, because otherwise your model will be garbage. So that's one thing. And also from my perspective, we need to be able to document. When you have so many models running in production, you do a lot of different things. You need to be able to document all these things. So there need to be some kind of processes in place for how does the team actually document things. I mean, we had some cases where I needed to look into some information, and I couldn't find it because that person was on holiday, and the person didn't check in their source code in Git. So I mean, look at and you could have other cases where you had some person look into specific features, and at that point that person left the company and took the knowledge with them. So then you had to, in theory, to redo the whole thing. Then if you look on deployment, you need to automate that stuff, and you need to test it very thoroughly. So you both need to test, in our case, do you have a model that it can actually execute fast enough? So we have some latency requirement on our model, so you cannot have a super duper complex model that takes 1 second to execute. That doesn't work if you need to score it real time. So that's some test, and you need to be able to, when you deploy, that it doesn't break the entire system. Then when the model is in production, you need to ensure that your platform actually have the right availability to be able to score all the time. You can't have a system that's unavailable 90% of the time. So ensure the availability as well. Then of course you have some system calling, in our case, the fraud engine calling our system and using the data. And then one very important part is also the whole monitoring part. Because if you don't know monitoring, then you don't know what actually goes on. So you should both monitor the platform. Maybe that's not the data scientist part, but you should actually also monitor the data that flows into the platform. So both the data that goes out and the data that goes in. And of course you need to model or monitor. Do you have a model drift? Are the models degrading? And there could be different reasons for this. Of course, there's okay, we have new fraud cases coming up that could result in model degradation, but it could also be in case that you have some of our upstream systems, they change some of their features, which actually could result in degrading our model. So that could be another cause there. And then of course when you go through this thing, you also need to consider we need to have new data sources on. We need to enhance the platform. Yeah, just to sum up, so basically first you need a fast and reproducible development lifecycle. You need to have reliable retraining and also do this quite fast. You need to have you need to monitor the platform and the models, and then just automate as much as possible. So you can focus on here where it actually brings value to the business. And then a lot of people talking about, I mean, we also had talks about how do you actually do this in operation. And you have these topics like ML ops, data ops, or analytics ops. But basically, it's taking the things from the best practices from DevOps and applying it here. Yeah, then finally I'll go into some of the stuff we've done on deep learning. So this was kind of more on an experimental stage to see if there's any proof of value in applying deep learning. So what we actually looked into was different kind of architectures on the fraud data, and compared to what the transaction on the platform right now, we only see the transaction as a single instance. We don't have the 10 past transaction. But what we did in this case was also include the most recent transactions as well. So what we looked into was these kind of LSTM, these kind of recurrent neural network, where you have this kind of memory in the neural network to capture these sequence data. Then we also looked into these more generative models. You have autoencoders, which is more you can use those both in a kind of unsupervised or semi-unsupervised fashion, where we would train the network only on the transactions where you don't see fraud, and then what you actually do is you kind of squeeze the data through, and then the middle layer would kind of compress most of the most important information. Then you would decode it again, and then you would kind of compare the inputs and the outputs of the neural network to see what's the difference there. For example, compute the mean squared error. And then when you kind of, the theory is that then when you feed in your anomalies, then this error will actually be higher than the network will not be able to reconstruct the transaction that well, so you would have a higher mean square error. Then we also looked into these convolutional nets, which are often applied into image processing and image classification, for example. But one of the challenges here is how do we actually represent fraud as a picture? So how we went about that is, if we have like the transactions here, so we had like 10 a time series of transaction here, and for each transaction we had 50 features. So in order to like translate that into an image, what we did was for each feature we found the eight features that correlated the most with that feature, and that kind of padded it around it that way around. And then we did that for all the features horizontal, on a row wise, and then we did that for each time instance there. So you kind of create like an image of the fraud. So I think maybe could be relevant for you guys if you have also transactional data to kind of what kind of methods could you actually use to transform your data into an image so it's actually applicable for these kind of models. And what kind of results did we actually see? We saw that, so the green here that's the res nets, where you have a kind of residual training on your convolutional net, which actually perform very well. What we see here is like the receiving operating curve. And on fraud, what we want to focus on is like the left area, because we're not interested in having a lot of false positives. So where you want to have your lift of your model is in the left part of the curve here. And here the ResNet perform very, very well. So more or less by having a very small number of false positive, you could have a detection rate of almost 50%. That compared to the rule engine is approximated to be around here. So the results are very promising, and we're kind of looking into how can we actually deploy this later on. And then just to sum things up, I found this quote on the internet some weeks ago, and it actually resonated quite well with what I've seen and what kind of things are we actually facing. It is that like 90% of the effort in successful machine learning is not about the algorithm, the models, or the learning. It's about the logistics. And I think this is really actually true to some extent. So need to be aware of the logistics, need to have like the entire process around it in place so you can have a good life cycle of the models. Any questions from the audience?